Hello out there in remote learning land. Today we are chatting about how to measure this moisture in the air, right? Yesterday we talked about humidity, what relative humidity is, how that relates to weather. Well, today we're going to talk about how to actually figure out how much moisture is in the air. Okay, let's get started. I'm going to start out with a funny little blooper, if you will, from a weather forecast. See if you could pick up on his blooper.
Then just a subtle wind shift on Thursday, and all of a sudden 80-degree temperatures are reachable over the weekend, 15 degrees above the average of 67, low and middle 80s this weekend. It's 69 right now. The humidity is not 666%. That would be very, very high. But it is moderate right now. That's just my poor typing skills. 75 degrees the high number on the day. The average is 69, and everything else looks like it's correct right there.
All right, so yes, the highest humidity normally should go is 100%, right? That was his typo. Maybe you've heard of a condition called supersaturation, where temporarily, it can jump one or two, points higher than that. But for the most part, 100 is as high as it's going to go. And of course, that would be a super high probability of rain that day. This instrument behind me is called a sling psychrometer. And if you take a look, it's basically just two thermometers attached to this piece that swings around on a chain. You literally just swing it in the air outside. And there's one thermometer that has a little wet sock on it. They call that a wet bulb. And the other is just a plain dry thermometer. They call that a dry bulb. And you swing it around about 30 seconds outside and you'll get two different readings. Because the wet bulb has water on it that evaporates. And when water evaporates, that lowers the temperature, right? Evaporation is a cooling process. So you'll see two different temperatures here, right? The dry bulb has a 20, the wet bulb has a 15. With that data, you can figure out the relative humidity outside plus what the dew point temperature needs to be or is. And that'll tell you, of course, how much the temperature has to drop for that air to become saturated. Okay, so get your definition down there. That is a sling psychrometer, right? The instrument used to measure dew point and relative humidity. All right, a couple tips here. Dry bulb is the actual air temperature, right? It's just another way of saying it. Wet bulb measures the moisture in the air by evaporation. There's that sock I was telling you about. Because evaporation is a cooling process, the wet bulb temperature is usually lower. Okay? Okay. So we're going to use that data of 20 and 15 to try to figure out the humidity and the dew point. All right. So these charts are in your reference tables. There's our data, right? Dry bulb is 20. That's the air temperature. Wet bulb is 15. Now watch what you have to do here. Okay? On this chart, the dry bulb is on the side. On the top, it says it's the difference between the wet and the dry. Well, difference, you remember from math, means to subtract. So here you're just going to take the regular dry bulb of 20, right? You're going to circle that and, of course, put your finger on that. Then you're going to have to subtract these two to get the difference of 5, and that's what goes up there, okay? So there's the 5, that's the difference. Here's the 20, that's the dry bulb. Now from here, you just kind of make them meet. You go down, you go across, and where they meet, boom, you're on the dew point chart, so that's the dew point. The dew point is 12 degrees. It is not close to the dry bulb, right? 20 degrees is pretty far away from that, so the air is considered to be relatively dry. Okay? You wouldn't get a rainy day with these conditions. It'd be relatively clear skies. Let's try this one. So now we have a dry bulb of 2 and a wet bulb of 2. Now they're the same, okay? So now when you do your subtraction, right, you get a difference of 0. Well, the difference of 0, that's the difference, goes here. The dry bulb of 2 goes here. And when 0 and 2 meet up, well, son of a gun, your dew point is 2. You're already at your dew point because the air is already saturated, okay? And there it is. They're equal, right? It's going to be 100% humidity. Probably going to rain. If not, it's going to be the foggiest, muggiest, most humid day possible. All right. Now let's try to work backwards for a second. Let's say that your difference was 10, so you would go here, and your dew point was 6. Well, now these are dew point numbers in the chart, so you would drop down from 10 and go down to 6. Okay, now it wants to know what's the dry bulb. Well, slide over, because this is the dry bulb column. Slide over and you get a dry bulb of 24. Okay, there it is. Well, now what is the wet bulb? Well, we have a difference of 10. The dry bulb is 24, so you say, all right, 24 minus 10 gives me the wet bulb, and of course, that would be 14 degrees. Okay? So you can use these charts a couple different ways. You can go forwards, backwards, or kind of in between. Either way, the goal, of course, is to get these two numbers to meet up. Once you get these two to meet, it can ask you for anything where they connect. All right. You use the same method for the relative humidity charts. The same exact method, it's just these numbers instead of dew points are relative humidities. So let's say you got a dry bulb of 20 and a wet bulb of 15. First step, take your difference, right? Your difference, of course, is 5. Now, take your dry bulb of 20 and your wet bulb of, your difference, or depression sometimes they call it, of 5, and make them meet. Right? You meet at 58. Now, that is a relative humidity. So you would say, oh, it's 58% humidity outside right now. Okay? That's comfortable for humans. Us humans like it between 40 and 60% humidity. Once we go beyond 60, it starts to get kind of sticky and uncomfortable. Our sweat doesn't evaporate, so we can't cool off. And once you go below 40, then the air starts to kind of suck the moisture out of your body in a sense, right? It makes your skin drier. You get chapped lips. Could even start to get bloody noses as it dries out the capillaries in your nose. When you breathe in that dry air, the capillaries crack and you start to get a little bloody nose there. Okay? So 58% is a pretty nice day humidity-wise. Of course, it's all relative to the season, but then we have over here. So similar as before, now the dry and the wet bulb are the same, which means the air is already saturated, but we'll work the numbers. So a difference of 0, right? That's going to be here. You have a dry bulb of 10, that's here. You make the two meet, and sure enough, it says 100% humidity. If the dry bulb and the wet bulb are already the same, then it's already 100% humidity. All right, you're going to have clouds, very humid, a very, very good chance of rain, of course. The pressure will be low, right? If you're talking very humid, it's going to be low pressure. All right, let's try this one over here. We have a difference of 8, so that's going to go straight to there, right? This is the difference. You have a relative humidity of 47, so now it's going to try to work you backwards. So 8, you go down to 47, and then you'll go over, right, to get the information. So watch. 8, down to 47, over, and of course our dry bulb is going to be 28 degrees, and that's why that's right there. Now it wants to know the wet bulb. Well, that's pretty easy, right? If the dry was 28 and the difference was 8, you simply go 28 minus 8, and you get a difference, of course, of 20 degrees, right? That's your wet bulb there. All right, that's how you use the charts, folks. The biggest pitfall I've seen students make is that they don't realize which chart they're on, so they go through the whole thing properly, and the next thing you know, they either write the wrong answer down, or the multiple choice doesn't offer it as an option because you're in the wrong chart. All right, so make sure if you're looking for humidity, you're in this chart. If you're looking for dew point, you're in the dew point chart. Okay? A couple other final tips. If there's a big difference between the dry and the wet bulb, it's a dry day, a high pressure day. There'll be no chance of rain, right? Lots of evaporation, etc. If there's a small difference between the wet and the dry, it means they're close together. The air is close to saturated. Going to be a lot of humidity, less evaporation, a low pressure day. And of course, if they are the same, it is 100% humidity. There will be no more evaporation. It's extremely low pressure, and it's probably a stormy day. Okay? All right, so at this point, review anything you got to go back to. Check out these summary questions in the end, and I'll meet you back in the meet.